So in this question, magnesium oxide is having a high melting point. Why? You have to identify the type of a compound first. Magnesium is a metal and oxygen. So magnesium is a metal and oxygen is a non-metal. So metal plus non-metal combined with each other. As a result, they will form ionic bond. So ionic bonds have strong force between the ions. Then carbon and oxygen means non-metal combined with another non-metal. So they will have a covalent bond between them. So if there's a covalent bond, then there are two possibilities. It might be a giant structure or it might be a simple structure. Because when a compound is having a covalent bond, it may be a simple structure, it might be a giant structure. But because they mentioned it's a low melting point, it means it is having a simple structure. Because if it was a giant structure, it should have a high melting point. And if it's a simple structure have weak, why they have a low melting or a boiling point? Because they have a weak force between the molecules, or weak forces are there between the molecules which are attached. So magnesium oxide, it's an ionic compound and there will be strong force between the ions. So A and B are totally wrong. Cannot be an answer. So we are left with C or D. Because C is strong force between the ions, D is also strong force between the ions. Then what about carbon dioxide? Carbon dioxide, which is CO2. So there is a not weak attraction between the atoms. Between the atoms, there's a strong attraction, like this is a structure of carbon dioxide, which is CO2. So between carbon and oxygen, the force is strong. But between the molecules, the force is weak. Like this is one molecule of carbon dioxide, this is another molecule of carbon dioxide. So between these two molecules, the force is very weak. But within the atoms or between the atoms, this force is a very strong force. That bond is very strong. So which one it match with? There is a weak force between the molecules and strong force between the ions. So it matches with option D.